yesterday evening, my wife and I went to the wedding reception of my wife's colleague's good friend's daughter's wedding, so I did not film. No matter. Okay, finishing off corollary was mentioned at the end of the previous session. No proof given in the text because it's probably, given that there were two very similar type corollaries earlier on the previous board, I've just left this one as homework for you to do. So here it is, corollary 3.19. So a language is decidable if and only if some NTM, so non-deterministic Turing machine, decides it. Now remember, deciding, that happens when a machine, when a Turing machine never loops, right? It's either, the machine either, well, it halts, it always halts, either in an accept state or a reject state. So the non-deterministic TM, the NTM, all its branches, so if it's a deciding NTM, all its branches halt. There's no branch that goes on forever. So that's a deciding NTM. And so if you have a deciding NTM, that's the language that deciding NTM generates, that's a decidable language, okay, by definition. So you can, so left as homework, you can prove that one fairly readily, just modelled on the previous two, so not hard. Hence no proof given in the text. So homework. All right, talking about variants. Still another one of Turing machines. This one is called the enumerator. So it's to enumerate in ordinary English means to give a number to, like for example giving a number as an ID, identifier, to, for example, citizens under a government. The government gives identity cards, IDs. So each citizen is enumerated, in a sense, given a unique integer that labels, in a sense, that person for administrative purposes. British and Americans tend not to do that, but in practice, for example, in America, the same purpose is served by driver's licenses. So all kinds of administrating institutions ask for Americans' driver's license to ID them, to identify them, to enumerate them effectively, because driver's license, it's a number. Alright, so a Turing machine that is an enumerator, what's it doing? Well, effectively, when it accepts a string, remember a language is just a set of strings. So when this Turing machine accepts a string, it types it out. So think of an enumerator as a variant of a Turing machine, and the variation is that it has an extra feature. It has a printer. Okay, it has a printer. So so this kind of thing, that would be an enumerator. So here's your your usual control, and here's your single tape, standard model of a Turing machine. But it has this extra thing, a printer, and each time the machine recognizes accepts a string, it prints it out. Okay, that's effectively the feature of an enumerator. Okay. Now you've heard the term Turing recognizable. Now remember, a machine recognizes a Turing machine recognizes an automaton recognizes a language when it accepts all the strings in that language and rejects all the strings that are not in that language. Okay, that's what recognize means. So Turing recognizable just means that the machine that's doing the recognizing, accepting all the string members of the language and rejecting all the rest, strings not of the language, that automaton is Turing, the language is Turing recognizable if the automaton that's doing all that accepting and rejecting is a Turing machine, so Turing recognizable. I mean, you could talk about, if you wanted, finite automaton recognizable, because that would be that kind of machine that recognizes the strings. Less of them, the language, the class of languages recognized by finite automaton is less than that of a PDA, push-down automata, an automaton with a stack with infinite memory, but not universally accessible. With a stack, you can only access the top of the stack, the contents, the symbol at the top of the stack. And in turn, the Turing machine more powerful than the previous two because, well, effectively because its memory not only infinite but is infinitely accessible. You can get to it, any element to it. Whereas, I mean, you can get to the symbols on the stack, but all those elements that you pop, if you need to memorize them, you'll need infinite resources in your the number of states, which has to be finite for a PDA. So you've got a problem there. So Turing machine more powerful than a PDA, because not only is its memory infinite, but it's infinitely accessible. You can get at it. You just move. I mean, you just move the head, and that doesn't require an infinite number of states in your big queue for your machine. Okay, so now earlier sort of tend to have dropped out a bit from popularity. The term Turing recognizable was called, a lot of people use the term recursively enumerable. So this term enumerable, the term recursively enumerable came from the concept of the enumerator, which I'll get into a bit more in the second square of this session. And recursion. We've talked a little bit about that. We haven't focused too much on it. We will more so future chapters. But anyway,